Hello everybody and welcome to Human Systems Engineering 542. Today we will be talking about instructions or designing instructions for use. Sometimes people call them IFUs for instructions for use. That includes everything from a user manual to on-product labeling, packaging, product inserts, all of those kinds of things. And the idea is for it to provide us operational information, which might include everything from how to use the device, why and when the device should be used, technical specifications, maintenance requirements, troubleshooting information, and risk-related information like warnings and things like that. And you might ask, as I often have, is do we even need instructions for use? Can't we even make the product or the user interface so easy to use that we don't need user instructions at all? And while this would be ideal, for many products that just doesn't work out that way. It's impractical. We still sometimes need to know information on how to assemble things, how to use them, maintain them, clean them, store them, how to dispose of these things, and even how to reuse a device. And that information is not easily captured in the user interface, and we end up overburdening kind of the other components of the user interface if there's not some instructions for use. One of the problems with instructions for use is it's been treated kind of as a secondary citizen when it comes to the user interface. That is, people often don't think about the instructions for use as part of the user interface, but indeed it is. Other times people treat instructions for use as just kind of checking a box. That is, it's left until the last moment to complete and create, and it's kind of treated as an afterthought. And then finally people will say things like, well, nobody uses the instructions for use anyway. And there's some truth to that, but they're particularly unlikely to use instructions if they're not very good. And I think that's one of the things that ends up happening is often the instructions are so terrible, of course people don't use them. And it may turn out that even if they tried using it, that is using a product first and had to rely on the instructions for use later, at least we should give them provide them with a very good experience for those instructions. So when we take an approach to developing instructions for use, of course the best one to take is a human-centered design approach, which we've discussed throughout this course. It involves an early and constant focus on the users and their tasks and their needs and goals and so forth. The ability to use data to help guide our design decisions, and iterations. That is, trying things out, seeing if people can use them, and fixing them based on that. And the iteration mechanism that we usually use here is usability testing. That is, people will conduct real honest-to-goodness tasks using the instructions for use. We find out where they have difficulties. We find out which tasks they're not able to complete. We find out which instructions don't seem to make sense for them, and then we go back and we fix those things. And the fact is, of course, this works for all user interfaces, regardless of whether you're developing a physical device or instructions for use. That is, these human-centered design principles really do apply to the design of just about everything. And of course, instructions for use are no exception to that case. We also start by designing early. One of the problems with designing instructions is people wait until the last minute to do this, and that's not a good approach. Instead, we should start, much like we do with developing the rest of the product, by understanding our user profile. Are our users beginners? Are they experts? Are they frequent users or infrequent users? What's their education level like? What's their literacy like? Etc. And we need to be able to understand those kinds of things in order to understand who we're designing for. The FDA recommends content created for lay users, that is, people who are not medical specialists, should accommodate at least a 4th to 5th grade reading level and no higher than an 8th grade reading level. And the idea is simply that there's a large number of people out there who don't read above 8th grade but still end up using these products, and we should be designing for them as well. Then it's important to develop an environmental profile. Of course, the environment of use impacts the user's interaction with the instructions for use, and that could include everything from the lighting to noise and distractions, how easy access is to technical support. We should consider the user's tasks, conduct a task analysis ahead of time, and identify all of the individual steps and tasks that need to be carried out, as well as the difficulties that might arise and the ways in which people could become cognitively taxed, as they conduct each of these user tasks. We should spend some time, there we are. We should spend some time making sure that we have the appropriate format. So there's all kinds of formats that we might use for instructions. They could be electronic instructions for use, so on the computer, for example, or on a device. Digital IFU formats can range in type, length, and interactivity, so some things could just be things like PDFs that we could include, but they could also be things like booklets or pamphlets or foldable inserts, quick reference guides, frequently asked questions, leaflets, etc. The other part I think it's important to point out is make sure that we're identifying the appropriate authors for these kinds of things. So chances are your instructions for use will be co-written by multiple people. Some of them will be subject matter experts. Other people might be people who have worked on the design of the product itself. And that group of people coming together is really important. You want somebody, on the other hand, who's a particularly good technical writer, who can design things and make them particularly easy for people to understand. And when that's the case, you end up with kind of the best results when it comes to instructions for use. So we've developed a framework for instructions for use, and you can really think about what people's tasks are when they're using instructions as involving three components. They start with finding the information that they're looking for. They often have a big document to search just to understand or to find the information that they're seeking. The second part is once they've found that information, they need to understand it. They need to comprehend it. And then the third is sometimes even after you understand it, it's helpful to look at the instructions at the same time you're doing a task, and we call that apply. That is, you must be able to use the information to conduct the task that you're trying to do. So find, comprehend, and apply are kind of the main steps when you're using the instructions for use. So of course, if we want to help people find information, we go back to our old friend, the ratio between signal versus noise. So of course, the famous quote by Albert Einstein was that everything should be made as simple as possible, but no simpler. And that's exactly the case here. You should examine every piece of information in the instructions for use to determine if they should be included or if they should be excluded. And if you can do that, you get to just the most important part, the real signal, and it makes it a lot easier to find a good signal when there's not a lot of noise around it, not a lot of excess information that's not very helpful. The second way to help people find information is just by organizing it really well. People have an easier time finding information in organized displays than in disorganized displays because they kind of have some hints about where to look. It also helps to put the most related information close together, just like we do in any other user interface, and separate related information for unrelated information using things like white space or blank space. Make sure you use consistent headers and font size and font weight, and that just kind of gives people an idea of the hierarchy of information and what's related to what information and how information is grouped. That can all be done through those things: headers, font size, font weight, etc. Then, when it's time, now they've found that information, now it's time to comprehend that information. They need to make sense of it, of course, and several factors make information easy to find also make them easy to comprehend. So it's easier to comprehend information when it's well categorized, when it's consistent, when it adheres to a hierarchical organization. So those two things go hand in hand. Another way of thinking about this, though, is by invoking what's called cognitive load theory. So cognitive load, you can sort of think about as the amount of working memory that's being applied at any one time. And there's three kinds of cognitive load. There's intrinsic cognitive load, and that kind of depends on the topic that they're trying to learn. So the more difficult the topic, the greater the intrinsic load, the extra work your working memory has to be doing. There's not too much we can do about intrinsic load, of course. It depends on the complexity of the device. On the other hand, there's extraneous cognitive load, and you can imagine this is the stuff we want to get rid of. So the difficulty of using the instructions themselves, that's influenced by the way information is presented. So good design reduces extraneous load. So the better you design, the less load there is on working memory, and the easier it is for people to operate this device and to understand the instructions. And then finally, there's germane cognitive load, and that's cognitive work when we learn new material, making sure we're committing it to long-term memory. And this is the reason you read the IFU to begin with, to actually learn. And germane cognitive load has a lot to do with that. So just adhering to this kind of approach, promoting comprehension really requires reducing extraneous load so that we could take those cognitive resources, which are pretty limited, especially with working memory and attention, and make that more dedicated to the germane load. That is the information we're trying to learn. Information is also easier to comprehend if it's chunked appropriately, and of course that's discussed in our cognitive psychology chapter. But of course, chunking is combining related things into one, which frees up working memory. It helps us do that by making meaningful items already stored in memory a part of what we're learning. So we can improve our chunking by describing tasks or steps with short, action-oriented sentences, and by putting meaningful things together. IFUs, on the other hand, again, instructions for use, are often chunked poorly. For example, they'll commonly present all disclaimers, warnings, cautionary language, all that stuff that we don't like to read at the beginning of the document. By the time you get to the part where it's actually relevant, though, it might not be remembered. And that's a real problem for people. So they might look at something or even decide to pass it over because they don't need it at that moment. And then it's not there when they do need it. It's just poorly chunked. It's not where it belongs, frankly. We also have the ability to comprehend information better if it's familiar to us. So using familiar words and icons and avoiding things like jargon and acronyms and so forth, that helps us become more and more, it enables us to comprehend information better because it's familiar. Being concise also helps simplify instructions. And again, facilitating learning helps if information is organized, if we use a metaphor, for example, to explain things in relationship to other things we already know. That's true of analogies, and illustrations are often helpful, especially when illustrations have text, descriptive text right by its side. Then finally, there's the issue of applying information. So sometimes people need to successfully apply that information to use the product. So sometimes people can't remember the exact steps to complete a task without having those instructions in front of them. And working with the product, while referring to instructions for use. So, other things that we can do to make this application easier, to make applying information easier, is to arrange things according to sequence so that they make more sense. So arrange instructions into tasks and subtasks and outline those things with numbers and bullets. We can also do things to help readers save their place. So while applying instructions, users might need to read a step, then conduct that step, and then return to what they were reading. We need ways to help people save their place so that they know their way back. And then finally, to provide feedback. That is, provide information about what users should expect to see, hear, and feel when they do something correctly. If something's supposed to click into place when they do something correctly, make sure you tell them that in the instructions. And use descriptive language as visual, tactile, and auditory feedback cues. So for example, with that click, you might put in an illustration, a little tag that says click. So people know that they're expected to hear a click when they place something in the right spot. Well, I hope that's helpful for you. A quick overview of instructions for use, but you can see that to a large degree it's a simple extension of the human-centered design process we've been following all along. And I hope that you will continue to apply that kind of process and you find it helpful. Thanks, and I'll talk to you next time.